All right, so if you look at, let's do the last one, number 31. So number 31 gave you negative pi over 6, and the direction said evaluate, if possible, sine, cosine, and tangent of the real number. And then on the assignment sheet, in parentheses, what did I say? Graph the angle. Okay. Because that really is an angle, even though it's a t. It's a t instead of a theta because the t is radians. So we're going to graph this angle, starting with the circle. Yes, you need to draw a circle because it's on the unit circle. It's where the radius is a value of 1 and it touches the edge of the circle. And then inside the circle, we have the x and the y axis. The other thing when you're graphing, because this is a question on your quiz tomorrow, you need to have the direction the angle is going. If you don't, then I don't know if you've graphed a negative pi over 6 angle or a positive 11 pi over 6 angle. So make sure you have the little direction. So since it's negative, it goes down, and pi over 6 is the first little angle that we encounter when we go down. So this angle represents negative pi over 6, which is the same as the other angle going around. Its coterminal angle is, anybody know? 11 pi over 6. Yeah, so nice job. All right, so if you're asked to evaluate means find and answer. That's what evaluate means. What is the ordered pair that corresponds with either 11 pi over 6 or negative pi over 6 because they're the same angle? They begin and end at the same place. So what would that ordered pair be? So any angle that has a 6 in the denominator. It doesn't matter if it's a 5 pi over 6, an 11 pi over 6, a negative pi over 6, a 7 pi over 6. If it has a 6 on the bottom, it's going to have those same two numbers, square root of 3 over 2 and 1/2. So whatever it is on the top, as long as there's a 6 on the bottom, it has the same two numbers. The reason I ask you to draw it is because you need to know where that angle is located so you can assign a negative or a positive value with the x and the y. Because it's in the fourth quadrant, the y value is negative because it's down below the x-axis. So then it says to evaluate. And evaluate for sine of the angle, cosine of the angle, and tangent of the angle. This point represents two of these three values. So the square root of 3 over 2, Rebecca, is which tangent or trig function? It's cosine. So this is cosine, and we'll review that today as to why it's cosine. And Rebecca, the negative 1/2 is sine. So there's no work that you need to do besides sketching a little diagram, because the sine of negative pi over 6 is negative 1/2. The cosine of negative pi over 6 is 3 over 2. But you do need to do a little bit of work for the tangent. And I know we didn't talk about this yesterday because I didn't get to it and I really wanted to. However, at the very bottom of that first page of trig facts, the second term tells you about tangent. So the second to the last term, sorry. Second to the last term tells you about tangent. What does it tell you about tangent? If you look at the second to the last term. It's sine t over cosine t. So if I have the sine and the cosine, and it tells me to take the sine t and the cosine t, I can take those two numbers and divide them. So my sine is negative 1/2. The cosine is the square root of 3 over 2. So literally, I'm going to take the sine value divided by the cosine value. And then you have to do a little bit of simplifying with the complex fraction and with radicals. The first thing, make it easy on yourself. If both denominators are 2, what happens with them? They Cancel. Okay, so they're gone. Now I have a negative 1 and a square root of 3. What do you have to do with that? And that's called rationalizing. So multiply both by the square root of 3. On the top, I now have negative 1 times the square root of 3, or just negative square root of 3. And then on the bottom, the square root of 3 times the square root of 3 is 3. That's how I find the tangent. There are going to be days where we don't cover everything. You have a book? You have an online, World Web, Google. But you are going to have to try and figure things out on yourself. I teach as much as I can in 40 minutes, but I just don't get to it all the time. Questions? So today, we are going to talk more about these 3, but we're actually going to talk about 6. So in algebra this year, in pre-calc, we've already reviewed more like linear, absolute value, quadratic, cubic, quartic, any polynomial, rational, radical, exponential, logarithmic, 10 functions we talked about in, 3 months ago. We're going to cover 6 trig functions today, because there are 6. And then pretty much you've seen all the functions that exist between algebra and trig. So at the top of page 13, I don't know, I have too many numbers running on my head tonight. Am I right, 13? Yeah. It says the definition of the trig functions. And I'm going to define them by using a picture. That's the wonderful thing about trig. Everything goes with a picture. So if you are a visual learner and you can draw yourself a picture, then you have a diagram to look at to help you kind of understand what it's talking about. So let t be a real number and let xy be a point on the unit circle that corresponds with t. And draw myself a circle. And that's a pretty darn good circle. I know I have that little circle button up above there, but too many things to click and it's too high. In that circle, I'm going to draw my xy axis because every unit circle really has an xy axis in the middle of it. And then I just want to visually kind of show you, remind you what this is kind of talking about. So we have a real number t, which is actually an angle, just like the negative pi over 6 we just looked at. So starting in the origin, positive x-axis, and rotating somewhere is an angle. And that angle is whatever it happens to be, pi over 3, pi over 7, pi over 6, any angle. That angle corresponds with a point wherever the terminal side is touching, and that point is xy. Yesterday we had a triangle, 2 of them, that we used to create the unit circle, and that triangle helped us find that point, because really embedded inside the circle is a whole bunch of triangles to tell me the location to get to that point. So if I'm graphing just a regular xy point, I would go over a distance for x, up a distance for y, and then if this is the unit circle, the radius of my circle, or the hypotenuse of the triangle, is 1. Now I have a triangle inside my circle. So if I want to find the sine of t, the sine of the angle, using SOHCAHTOA, because that's what you know. That's what you did in geometry. What 2 sides of a triangle is SOHCAHTOA for the sine? So sine would be what over what? Kevin? Using SOHCAHTOA. Opposite over hypotenuse. So it's opposite over hypotenuse. That's the old.
Oh, okay.
So the old is opposite over hypotenuse. Kevin, if you look at your angle, which is always a central angle, always connected to the center, the opposite side of this triangle is, and the hypotenuse is 1. So the reason the sign is y is because the opposite side is always y. The angle is always in the center. So if I go across from it, that vertical side is going to be y. The hypotenuse is 1. It's a unit circle. That's why the sine is the y value. So cosine is old adjacent over hypotenuse. So that would be defining it using SOHCAHTOA. But now looking at my triangle, the cosine is x over 1 or just x. And then the tangent we know is the opposite over adjacent. Or if I look at the triangle inside the circle, what is the opposite in the adjacent? Y over x. So now I have a way to define or describe the three functions just using an x and a y. And that's how we will define them pretty much from here on out. We won't really think of opposite over hypotenuse. If it's on the unit circle, it's y over x for the tangent, or it's just y, or it's just x. Now this only is for the unit circle, because it has to be a 1 for a radius. So there are three functions right next to it because there are 6. Those three functions next to it are called reciprocal functions. I like to call them buddies, partners. But the sine function, S-I-N-E, goes with the CSC function. So these guys are related, they're reciprocals. Does anybody know what the CSC stands for? Somebody, Kevin, was that you? Not cosine. Ellie? Cosecant. Nice, Ellie. So if math were nice and it made sense and it was logical, you would say, well, the sine and the cosine should go together, because co usually means it goes with something before it, sine, cosine. But it doesn't work like that, because these are my 3 original functions, and they're not related to each other. I mean, besides being pieces of a triangle. But the sine and the cosecant are reciprocal functions. What does a reciprocal mean? So if I know the sine is y, what does the reciprocal mean, Emma? Yeah, the cosecant is 1 over y. That's what a reciprocal is. Place 1 on top of it. So if the sine and the cosecant are reciprocals, the sine is y, the cosecant is 1 over y. Ellie, the next one, what would that function be? Yeah, this one is the secant. It is reciprocals with the cosine. So Emma, if the cosine is x, the secant is 1 over x. Notice how I have a function that begins with a c and a function that begins with an x. A function that begins with the c and a function that begins with an x. They pair together. I can't have the same letters together. I have to have c and s together. The last one is the tangent and the cotangent. That one at least makes sense. One of the 3 makes sense. So Emma, if the tangent is y over x, what's the reciprocal of y over x? X over y. If you already have a fraction, you flip to find the recip. Oh. So if I have a fraction already, I flip to find the recip. If I have a whole number, I put a 1 on top. That's how I find the reciprocal. So either flip it or place a 1 on the top. So we're going to use these 6 trig functions and the angles that we talked about yesterday to see if I can find values for the 6 trig functions, or to see if I can evaluate an angle for those 6 functions. There are 5 examples down below. We're not going to get to all 5, probably 3, because I want you to kind of start the homework so you can kind of see what we're doing with the big picture and all of it together. So our first angle is angle 0. Evaluate the 6 trig functions. There are my definitions for the given angle. And the first thing it says is the point on the unit circle. So draw yourself a little circle. Put the xy axis in there. Connor, where is angle 0?
Just the right side of the x-axis.
Yeah, it's just the right side of the x-axis. So that would be my angle. What's the point, Connor, with that angle? What's the xy value?
1, 0.
1 is 0. Because I'm moving over the radius of 1, but I'm not moving up or down. So my distance that I've traveled is just 1, 0. So now we're going to find the 6 trig functions, starting with the sine of 0. Make sure you put the angle next to it, because I have to find the sine of an angle. I can't just find the sine of nothing. So just like having a number sometimes in front of a variable, we need the sine of something. So then I have the cosine of 0 and the tangent of 0. And we'll talk about those three first. So if you look at your definitions above, using the ordered pair, the sine is equal to 0 because sine is 0. Sine is y. And cosine is equal to 1. Again, because the cosine is x. And using that definition, it says tangent is y divided by x because it was opposite divided by adjacent. So y over x is 0. That's it. Now I'm going to do the three buddies, the three reciprocals. So right next to it, we have cosecant of 0, secant of 0, cotangent of 0. So, Jacob, what is the cosecant of 0? What is 1 over 0? Undefined. That means the cosecant doesn't have a value for the angle 0. Jacob, what is the secant of 0? Because 1 over 1 is 1. And then how about the cotangent of 0? Yeah, because it's flipping to find the recip. So if I have 0 over 1, I flip it to get the recip. 1 over 0 is undefined. Questions? So we're going to do letter B. We're going to graph that pi over 6 angle, which we actually started out negative pi over 6 from the book. So we'll look at this positive pi over 6. I know. That would be nice. So graphing the angle. Was pi over 6 a little angle or a big angle? Little. It's the first one. So smaller angle. So I have the angle pi over 6. You might need to flip to see what the ordered pair is that goes along with it. You might not have that memorized yet, and that's okay. Jacob, what is the xy value that goes with pi over 6? Square root of 3 over 2 and 1 half. Right, square root of 3 over 2 and 1 half. Which, if I go back to the problem we did at the beginning of class, look at this. The square root of 3 over 2 and 1 half. It was negative pi over 6. That doesn't matter. It still is those same two pairs. So as long as it has a 6 on the bottom, it's going to have the same two numbers. This time they're both positive because we're in the first quadrant. So we're going to try and do exactly the same thing. We're going to get the 6 trig functions. Now we're looking at pi over 6. So Maya, the sine of pi over 6 is 1 half. It's y. Cosine. How do you find tangent? Perfect. So take 1 half y divided by x, square root of 3 over 2, and then simplify. So what happens to simplify? Perfect. So 2's cancel. We end up with 1 over the square root of 3. Multiply top and bottom by square root of 3, and we end up with the square root of 3 over 3. So there are 3 original functions, sine, cosine, and tangent. So right next to it, right, it's 3 buddy reciprocal functions. So cosecant goes with sine. Secant goes with cosine, so I should have a co-function with a regular function. And then cotangent and tangent. So I need the reciprocals now. So Mackenzie, if we have 1 half for sine, the reciprocal is 2. And then we have to take the reciprocal for the cosine. So we have to flip that around. And then what happens, Mackenzie? Yeah. What's that become? Perfect. 2 square root of 3 over 3. And then to get the tangent, you can do one of two things. The definition for the tangent is y over x. So the cotangent is x over y. So I can take my x over y, or I can take the reciprocal of that answer there. Either way, you're going to get the same thing. So I could take x over y, because that's what the true definition is, x divided by y. So the square root of 3 over 2 divided by 1/2. Or I could just take the reciprocal of my answer for tangent. Either way, I should get the same solution. Kevin, what happens when I do the square root of 3 over 2 divided by 1/2?
You multitude, and then you left with square root of 3 over 1.
Yeah. I like doing it that way because then I don't have to rationalize it. Being lazy. A little lazy. Questions. So we're going to skip C, but we're going to go to D. I want to go to one that isn't in the first quadrant. So D says 3 pi over 4, and we haven't done an angle that has 4 on the bottom of it either. So now that I have a 3 pi over 4, the denominator is 4. 4 pieces of pi on the top, 4 pieces of pi on the bottom. Pie is one of the best parts of Thanksgiving dinner. Yeah, mashed potatoes. Well, I'm making caramel apple pie and pumpkin cheesecake. So I'm excited about my pie. Where is 3 pi over 4? Yeah. So say it again. 135 degrees. Or if I count 3 pieces of the pie, I have 1, 2, 3. So it should be the second quadrant. She said 135 degrees, or it's in the middle of the second quadrant. Taylor, do you know what that ordered pair is? Good. So there's our ordered pair, negative square root of 2 over 2 and square root of 2 over 2. See if you can get the 6 trig functions. Doing exactly what we did for the 2 above. So you got the point. With the ordered pair, we now need to attach that ordered pair using the definitions. Emma, what do you have for the sine of 3 pi over 4? And the cosine? And then the tangent is negative 1 because your y is the square root of 2 over 2. Your x is negative square root of 2 over 2. And I know if I take the same number divided by the same number, they cancel. So if I had a 5 divided by negative 5, I get negative 1. And I have the square root of 2 over 2 divided by negative square root of 2 over 2. I still get negative 1. So the same thing divided by the same thing, no matter how big or small the number, it still cancels. So when you're trying to find the cosecant, you flip to find the recip. So if I flip my fraction, I end up with 2 over the square root of 2. What's that become? Dylan?
Square root of 2.
Yeah, because top and bottom, rationalizing it, I get 2 square roots of 2 divided by 2. And those 2's cancel, just leaving us with the square root of 2. The next one, if I flip, I get negative 2 over the square root of 2. And Dylan, that answer is? Negative square root of 2. Thanks, Chris.
Yep.
Do you need me to sign this?
Thank you.
And then the last one is the cotangent. Well, if I take x divided by y, you're still going to get negative 1. Or I could say, I already have negative 1. It's a nice number, and if I take the reciprocal of that, it's still negative 1. Questions? So this section is just kind of getting you to understand that there are 6 trig functions, and also learning how to evaluate. We will obviously do more with it, but right now it's getting you to see the ordered pairs, how to calculate those ordered pairs or the functions from the ordered pairs. In your packet, I want to show you the wonderful trig chart. That's actually part of your homework, but I want you to see how the patterns work. And for some reason, I skipped pages and I put extra notes in between. But if you flip to page 19, there is a huge trig chart. Yeah. You figure there are 32 angles, and each angle has 6 functions. There's a lot of little boxes on there.
Wow.
Yeah. So we're going to go through and try and just get you to see the patterns, because it really is a bunch of patterns. But before we do that, I'm going to define each function just above it so that we have a little reminder. Sine y, cosine x. The tangent is y over x, so the cotangent, x over y. Y over x, x over y. Not in the right order. Yeah. The secant goes with the cosine, so the secant is 1 over x, and then the sine goes with the cosecant, 1 over y. So they kind of like work their way into the center. That was my logic. Obviously that logic didn't work, huh?
That threw me for a
Yeah, sorry. All right, the next thing I'm going to do is I'm going to put a little line at 90 degrees because 90 degrees ends quadrant 1. So I'm just going to remind myself, and you have extra space. I made my chart too big. This is quadrant 1. I have a positive x and a positive y. So every answer should be positive in that first quadrant, both x and y, anything that has an x and a y. And then when I get to 180, I'm going to put another little line because this is quadrant 2. What happens with quadrant 2 with x and y?
Is a negative x positive?
Right, a negative x and a positive y. Going down to quadrant 3, putting a line at 270, both negative. And then I know the last set have to be the quadrant 4, positive x, negative y. Okay, so my goal is to show you how this chart works in a very few little short of time. So I'm going to give you the answers to pi over 6.
Yes.
I know, right? That's really nice of me. So 1/2 square root of 3 over 2. Because the ordered pair is the square root of 3 over 2 and 1/2. The tangent is the square root of 3 over 3. The cotangent is just the square root of 3. The secant is 2 square roots of 3 over 3. And then the cosecant is the reciprocal of 1/2, which is 2. Remember, we can calculate them. We just calculated them in that, like the example. I just gave them to you quickly. But we already did calculate them. So now, here's how the chart works. Go to find your next pi over 6 angle. What's the next pi over 6 angle?
2 pi over 6.
5 pi over 6. So it has to have a 6 on the bottom. So 150 degrees, 5 pi over 6. Are any of the answers going to be different? No. So copy your whole list horizontally. So we'll talk, yep, very good, we'll talk about that. But right now I'm just copying the values because they are exactly the same if it has a 6. It's a family of angles. Except if it's in the second quadrant, anything that has an x is going to be negative. So cosine has an x, tangent is y divided by x, cotangent is x divided by y, and secant is 1 over x. That means that those 4 have to have negatives. So it's negative. And now I have my whole list for that row. So let's do another one. Go down to the next time you see a 6. 7 pi over 6. Copy the same numbers. What should be negative this time if I'm in the third quadrant? Both of them. So y is negative, sine. X is negative, cosine. What about tangent? Why is it positive, Kevin? Yeah, you got 2 negatives. You're taking negative y divided by negative x. Tangent's positive. What about cotangent? Also positive because it's negative y, x divided by negative y. And then the last 2 are negative. So you should see when you're in that quadrant, your answers for cotangent and tangent in that third quadrant, they're going to be positive. So is it a lot of work? Yeah, but really it's calculating the first 5 angles and then just do a lot of repeating. The goal of this chart is for you to see those patterns and how an angle is related to another angle because of the geometry. Questions? So tomorrow we're going to wrap up the section. We're going to deal with angles that go beyond 2 pi and again show you how they're related back to the original angles. It's all about the relation of these original angles. Have a fantastic day.